Hi, this is Chris Andrews. I gave a talk last week at the EuroSDR webinar on the use of 3D geoinformation. And as I've done with previous talks, I thought I would record it for sharing a bit more broadly with my network. So I'm Chris. As folks who know me already know, I worked with 3D groups at both Esri and Autodesk. In my career, I've heavily focused on topics such as 3D, AEC, GIS integration, digital twins, lots of different things spatial, including over into biology and other domains. And then I've been involved with open standards from a couple different perspectives. I was really happy to be able to speak at this EuroSDR event that was directed toward national mapping and cadastral agencies, and that's why you'll see some positioning around that in this talk. Many national mapping and cadastral agencies probably haven't even heard about this acronym BIM. Fundamentally, we lack enough resources to create and maintain all of the assets and infrastructure that will be required to support sustainable human habitation over the next coming decades and even centuries. Building information modeling was introduced a couple of decades ago in the architecture, engineering, construction world as a project management process for collaboratively creating and maintaining assets using detailed information throughout plan, design, and build. And what we've also seen is the intent of BIM has started to also filter forward into operations of buildings as well. For a few decades, practitioners familiar with both geospatial and BIM have understood that combining these two disciplines can lead to even greater accuracy around risk analysis and cost savings during planning and pre-construction, better coordination of design and construction across and within sites, and higher likelihood of compliance with requirements around everything from energy to environmental impact, safety regulations, and much, much more. For those national mapping agencies who have not really heard about BIM, it's important to understand that somebody in your country is highly concerned with BIM today. I dug this slide out of my archives. I had adapted and started using this slide back in 2017 to track the emergence of national standards for requiring the use of BIM in construction around the world. As you can see, I last updated it in 2019 because it was more than obvious that BIM was going to be basically a wave sweeping the entire world. A lot of this was kicked off in earnest by the UK, who implemented something called PAS 1192. One of the standards within that included a requirement for large construction projects to be built in geospatial context, which triggered a whole bunch of new interest in bringing together GIS and BIM processes. And we've really seen that explode over the last 10 years or so. So whether or not you're aware of BIM, BIM is happening in your country, and you have the opportunity to potentially influence it. So the role that NMCA is going to play in the conversation is specifically to be the owners of the spatial perspective on sustainable growth, natural resources management, sovereignty, and society within your national territorial boundaries. You can help influence and in some cases even set requirements and guidelines for the use of geospatial in construction, renovation, and even operations of buildings and assets within your country. You definitely can participate in standards discussions, and then you can even, your fundamental role that you actually play is to be able to create and foster geospatial data exchange, standardization, and accessibility across disciplines that can influence the life cycle of assets in the context of the national change that is happening everywhere around us today. It's super helpful for you to understand that by participating in the adjacent workflows that consume geospatial information, you may actually be enabling things like saving massive amounts of time and monetary assets on construction and maintenance of assets and buildings within your countries. I'm not talking about anything that is new or different going forward. It's actually possible to consume and use 3D BIM data in geospatial applications through standards today. There are many differences between traditional GIS data, reality capture information, and BIM data, not only during creation, but also when you analyze those data, store them, and provide access to them. There is a high-level technical language for working with BIM and geospatial information together. In some cases, that language actually has more to do with the business processes that the data come out of rather than the actual details about the data themselves. In many cases, one thing to keep in mind is that the concepts of temporal and spatial specificity and accuracy may actually vary across domains such as construction and architecture compared with the operational domains where GIS is typically traditionally used. So BIM and GIS integration tends to be driven by the business model under which the data were created, not the actual data itself. Traditionally, GIS data was often created over on the operational side of organizations. So it was created with the intent to be updated and maintained throughout the lifespan of those organizations. Those organizations that maintain assets, this may be a national government with a whole bunch of buildings in a national portfolio. This may be a university, this may be a utility. Operational entities that provide a service or services and that maintain and build assets to deliver those services, they will spin off projects that are handed over to typically to architecture, engineering, construction firms to essentially make change happen within those asset systems. In order to make that change happen, AEC firms will use tools such as AutoCAD and Revit and ArchiCAD and other tools in order to build design data and to do planning and document the information that will be required to construct and then hand over those assets. Data is really constantly flowing throughout this system, and it's important to understand that different stakeholders within the system are going to be creating, maintaining, and using data for different purposes at different rates. And it's a continuous job to make sure that those who need to consume data for different functions are doing so with the understanding of why the data was created. When I talk about BIM data, I'm typically referring to 3D and sometimes 2D design data that is used to construct and in some cases maintain or otherwise modify infrastructure and buildings. In reality, BIM data can include schedules, bills of materials, inventory lists, safety inspection reports, and many other types of data that may not be initially intrinsically geospatial, but which often can be tied through 3D design and 3D and 2D design data and geospatial information in order to view it in broader project context. When it comes to the 2D and 3D design information that we're going to talk about here, we'll mainly focus on something called IFC, which is an open standard that is maintained by Building Smart International, and which contains a rich schema and semantics for identifying not only the 3D components of infrastructure and buildings, but also many of the metadata and attributes about every little piece of those buildings and infrastructure assets. Typically, what we see, however, is that IFC and other types of 3D BIM data can become very dense, and they're not really built for streaming very large data sets. So if you want to, for example, have an entire campus and BIM data streamed into a lightweight web scene, there are some tools for doing so. But when it comes to then putting them in geospatial context, there have been specific standards created for helping create those experiences. Two that I've specifically worked with include OGC I3S, which was created by Esri. It was submitted and approved as a community standard back in 2017, so it's been around for quite a while now. I3S supports complex 3D scenes with multiple layer types that feel somewhat like GIS layers, which was how it was intended. It's I3S tends to be closely aligned with GIS publishing workflows. It supports very broad set of horizontal and vertical coordinate systems. And importantly for this conversation, it includes an explicit notion of building-oriented content, including support for MEP type features and attributes, as well as things like floors and other aspects of buildings. OGC 3D Tiles is another community standard that was approved back in 2019. It's designed for scalable streaming of heterogeneous 3D content, kind of brought together in the same 3D structure underneath. It's built on a flexible tile set structure with hierarchical level of detail, and it's kind of a general purpose framework for streaming 3D. 3D Tiles today primarily supports WGS 84. It can be used for buildings, BIM, CAD information point clouds, terrain, and photogrammetry. But as we'll see in later slides, it does not typically support a standardized schema for BIM information. Before I dive in any further, I'd like to just show a couple of quick demos here. This one was given to me by a team at Esri, and what you can see in their web experience is that they support bringing together many different types of geospatial information, including things like LOD to buildings, points for trees, surfaces that can have nice textures for things like water. And you'll see they can bring in reality capture meshes, which is what we see here. And even within those reality capture meshes, they can even then bring in detailed BIM information, such as this train station. On top of that information, you can actually inspect it to see the metadata about the BIM itself. And then you can even do things like overlay, like cloud captures. So within the Esri-based experience, you can see that you can bring in a whole bunch of different types of geospatial data, basically handle the data as it was originally designed, and then create experiences with the data in geospatial context. Christophe Lawrence lent me this video showing an application that he built that brings together 3D tiles with the help of cesium.js. In this cesium.js experience, you can see Christophe has brought in cesium's global data, a BIM model, and other 2D and 3D information to put a building in geospatial context in a global scene. And you can see that Christophe has used some of the tools that he has available to create an experience for browsing metadata on the BIM model, looking at individual assets within the model, and then actually performing other analyses and exploration on and around that BIM data itself. In this case, Christophe has basically substituted a whole new site around an existing building, and then he's going to show some other interaction with the scene that's possible within Cesium. So in both of these experiences, what we've seen is you can bring together a variety of types of geospatial information, put it on a globe, or in the case of Esri, put it into a local Cartesian scene, and then perform analysis and inspection on BIM data in the context of a full geospatial experience. When it comes to 3D formats, there are many different formats out there. When you're talking about bringing together BIM and GIS information, you're often focused on a few specific formats that it might include things like IFC and I3S and 3D tiles that we've already discussed. And then you'll also hear about things like City GML or a derivative called City JSON that is a well-established standard for representing buildings, not typically at BIM level of detail, but it's been in use for quite a while now. Kronos Group is a graphics-oriented standards group that maintains this thing called GLTF, which is kind of like the payload format that is used within 3D tiles and which can be used in I3S as well. And then you may also hear about things like universal scene description, which has been promoted heavily by NVIDIA in the last few years. It was originally created by Pixar with the help of Autodesk and others for representing very large film and game scenes, and it's being adapted for use in robotics, CAD BIM applications, and in many other ways. When it comes to the BIM world, you'll hear about a lot of different formats. As I said, BIM can include many different types of information well beyond 2D and 3D data. There's a list of them here. The list can get much larger. Some of the most notable ones you'll hear about are things like Revit files, Autodesk DWGs, maybe MicroStation DGNs. COBie is a way of storing building semantics, building information for exchange. And then there are new formats such as the BIM Open Schema created by Christopher Diggins that is basically a Parquet-based open interchange format meant for faster access and streaming. There are also a bunch of other more generic film and game industry, you'd say 3D formats, some of which come out of a wide variety of industries, really. We can set those aside for right now, but understand that once you start getting into 3D, you may be asked to bring together a variety of different 3D data types. When we want to bring BIM data over into geospatial, we would like to keep, in many cases, the semantics of the original design and construction data for use over in geospatial experiences. When it comes to I3S and 3D tiles, I3S actually has a well-defined building scene layer concept. It supports component level building organization. It has a natural fit for things like floors and disciplines and other building elements. And it is really good when you want to basically treat those different building components as if they're layers in a GIS. 3D tiles can also be used to store BIM information for use in a geospatial experience. It does not have a built-in BIM or building hierarchy. It has a more generic metadata structure that requires customization for bringing over converted data for use in a geospatial experience. It is very flexible, but tends to be less prescriptive when it comes to the structure of BIM information. Keep in mind that both formats are well adopted by commercial and open source tools. Both are royalty-free, they're actively maintained, and they're driven by community input in the OGC process. When it comes to using standards to create experiences that bridge multiple domains, what you'll often find is workflows that look something like this. When you're building BIM and GIS experiences, often you're really focused initially on the authoritative BIM information, which is what we see over here on the left. That information is kind of stored in its own native formats, which can include files, complex file systems, and definitely cloud services such as Autodesk's Format Cloud that they've rebranded recently. The typical workflow then to be able to use that data in geospatial context is to convert it in some way. Based upon what we're talking about here today, we're going to talk about converting it into I3S or 3D tiles. In some cases, you may also do things like convert it into CityGML, which you would then convert into, say, I3S or 3D tiles. And then you can load those standardized formats, stream them into experiences, everything from AR experiences to dashboards to mobile and desktop experiences. Because you've converted your BIM data into a geospatial format, that means you can then combine it with other types of geospatial information as well, which can include everything from reality capture meshes to vector tiles and even other traditional GIS data types. And those experiences can be built with Esri, with Cesium, with game engines, with many different technologies these days. When bringing geometry over from IFC, keep in mind that typically the source geometry is not perfectly preserved in either I3S or 3D tiles. Both are good for viewing that information. Essentially, in both cases, you're converting the geometry from IFC over into a mesh. In the case of I3S, you have node-based scene layer structure that actually works very well for kind of structured scene delivery and GIS-based display. I3S is usable in web, mobile, and desktop applications, and Cesium, just like 3D tiles is usable often with Cesium JS, but also in other web, desktop, and mobile experiences as well. 3D tiles typically tends to store everything as a GLTF-based tile. The one advantage of using 3D tiles is that the group that maintains it tends to be a bit more aggressive about jumping on new industry-derived compression and streaming improvements, and it works well, especially for browser-based rendering and scalable 3D streaming. What about all the metadata coming across from BIM information? So I3S has very strong support for feature-based identity and attributes. As we said, I3S already includes a profile for specifically storing BIM information, and this profile can be used for storing other types of physical infrastructure assets as well. And it's useful for keeping IFC properties queryable inside a GIS-style scene. Georeferencing is definitely one place where I3S today has a leg up. I3S explicitly supports a wide variety of coordinate systems, and this can be helpful when BIM needs accurate placement into larger GIS scenes, and when you're working in an environment that has statutory requirements for specific coordinate systems. 3D Tiles has a strong metadata system with very flexible attachment points. It can be used to preserve a broad subset of IFC properties, but it is also going to be more heavily dependent upon custom export and conversion processes. Georeferencing today for 3D tiles, you can support local and global spatial placement within tile set structure. Georeferencing can be good, but depends more on export workflow conversions and conventions. And as I said, when you're working in most of the apps that actually consume 3D tiles, they typically will be WGS84 global experiences. So for IFC information persistence, I3S tends to be stronger when you want building where output has better alignment with floors, disciplines, and other structured building components. And it's a more natural fit for GIS publishing of BIM-derived building layers. 3D tiles tends to be stronger when you're more focused on building a web experience than you are on bringing across specific semantically structured data. It's good for mixed 3D environments, and the custom metadata model means that you really have a lot of flexibility to create the experiences you want. Keep in mind that neither format should be treated as an authoritative BIM data source. Full round trip is usually not going to be possible Source IFCs should be maintained, especially where they are required for legal or other compliance purposes. It is possible to go back and forth in many cases, but that typically will be done through extensive customization. So keep in mind that at the end of the day, a lot of this stuff is kind of in the weeds compared to what you're worried about on a daily basis if you're a national mapping and cadastral agency. However, you have the opportunity to influence the standards and information content about the built and natural environment that's used to manage and support the people in the country that you serve. And then through that, you have the opportunity to influence the broader international community, uh, which, as we saw earlier, the UK did so a few years ago, and to a huge effect on the world that we're in today. I3S building scene layers are a useful tool when your goal is to create building-aware GIS scenes and experiences with structured BIM-derived components and attributes. 3D tiles is really useful when the main goal is flexible browser-oriented streaming across mixed 3D content types. In both cases, as I've already said, you do want to preserve, in many cases, the original IFC and native source BIM files. When you're building applications, all right, so thank you very much for taking a few minutes to listen to this talk. I hope it was helpful for you. Huge thanks to Christoph Lorenz of GeoBIM App and Jasmine Du of Esri for sending me some great demos. If you have any questions, I'd be happy for the follow-up. Thank you.